So thank you all so much for joining us. We are here to talk about taking your UI test automation to the next level. As we've mentioned, or maybe we haven't yet, we're SmartBear and we're joining you from Boston, Massachusetts. So we want to do a really quick introduction. Nick, you want to start off?
Yeah, absolutely. So if you can't guess, I'm on the left in this photo. My name is Nick. I'm an engineer here at SmartBear, and I help all across the place with our testing products.
Yep. And my name is Bria, and I am on the product marketing team working pretty closely with Nick on all of our test products, which include products like TestComplete, QA Complete, cross-browser testing, and more. We really quickly wanted to do a quick overview of who SmartBear is. So SmartBear, we provide tools for development, testing, and operations teams to create great software faster than ever. We have over 6.5 million users in 194 countries and 22,000 companies. As we mentioned, we're headquartered in Boston, but we have 7 offices globally with our European headquarters in Galway. Founded in 2009, and we're a pretty big open source innovator. Some of our more familiar, popular products include Swagger and Soap UI.
And this is the brag stat here is that this new SmartBear piece of software is going to be downloaded every 3 seconds, which blows my mind every time I think about it. But the reach here is undeniable.
Absolutely. And we have a lot of really cool products that span the entire software development lifecycle. So from development through testing and operations at both the UI and the API layers.
Yeah, everywhere software gets built, improved upon, or maintained, we're going to have a tool in there to help you out.
So our focus, at least Nick and mine, is along the top row and in the middle of the diagram here. But please feel free to ask us questions about any of our products throughout this webinar, and we will be sure to get you that information, or at least point you in the right direction if we can't answer it.
We'll give it our best shot, you know.
We'll give it our best go.
If I don't know, I know someone who knows. So just throw them out there.
So with that, we're just going to go ahead and get started. We finished the SmartBear spiel, and now let's talk about what's the important things. What are we actually going to cover today? So the first thing in this presentation we're going to talk about is flaky tests. I guess actually this entire presentation is really going to be about flaky tests and how do we overcome the common reasons that we see for flaky tests.
How do you handle the flake? We're going to figure it out.
So the first part of the presentation, we're going to do an introduction to flaky tests and really, talk about why you should care. And I don't know about you, Nick, but like I really like to see the math behind things and understand how it can actually impact me, not just anecdotally. So we'll talk through some of that.
Exactly. And for those of you who the synonym doesn't translate, it's very early. A flaky test is an unreliable test. So if you've got no idea what we're talking about here, the concept is we're tackling how to make your tests just a little bit more reliable in the short term and the long term.
And so the second part, we're going to talk about exactly what makes those tests unreliable. What are the common reasons? We asked our internal team here, we talked to our engineers, we scoured the internet, we went through the industry and just talked to some of our influencers. And we're trying to understand what do you think are the most common reasons? And those are the ones we're going to talk through.
Absolutely.
Next, we'll talk about how to overcome these, recognizing that you can take a step towards improving the amount of flaky tests you have, but there are still going to always be some flaky tests. You just got to figure out how to work around.
Yeah.
So we recognize that. And so we want to talk about then with the ones that that are remaining flaky, how do you manage them? What can you do to improve on your testing processes, etc.? We'll finish up with a math example because math is the bomb. And
handwriting of the gods.
And then Nick is going to walk us through an awesome demonstration, putting together all the things that we learned with TestComplete. And as I mentioned, there will be a live Q&A at the end of the presentation, but please feel free to ask us questions throughout the entire presentation. We are closely watching.
Yes. Well, I am closely watching. She's going to be presenting. I'm going to be watching.
Thank you. Taking one for the team. And we'll definitely be able to answer those lives or by text. So let's go. Flaky tests. Let's talk about them. Flaky tests in general shouldn't be tolerated, and we want to show you why that is. If we take an example, let's say we have 300 tests in a test suite, and each test individually has a 0.5% failure rate, meaning that its pass rate is 99.5%. And I don't know about you, but like to me, that seems like a good pass rate.
99.5 is, if I got 99.5 on a test, I'd be ecstatic.
Yeah, man. Oh, I never got 99.5s on the test.
Straight D student.
But in general, if you get that grade or that pass rate, that's a pretty good pass rate. At least that's what our instincts tell us. But when you actually expand that pass rate out for the entire suite of tests, you're going to see that this actual pass rate is less than 25% for the test suite as a whole.
Eek. That's closer to my grades.
So even a passing rate of 99.5% for a single test may not be good when you actually look at it in the larger picture of a test suite. And this is an example of why the 0.5% really matters. Imagine if we could get that down to 0.2%. Our pass rate would increase a lot.
Yeah.
And that'd be really great. And your test suite would pass with a much higher confidence, and something that everyone should aim for. And this is why, at the end of the day, you really shouldn't tolerate flaky tests. And that 0.5% really matters. So if you can get it down even 0.1%, that's really, really helpful and can really impact your overall testing.
Yeah. And this speaks towards the concept of there always being room for improvement. Are 100% of your tests going to pass 100% of the time? No, absolutely not. But you should be trying to nail that down with all your strength, because if you can reduce that, like Priya said, even fractions of a percent, that's going to be reaping benefits for you in, again, both the short and long term as you move forward with your testing.
So we were talking with some of our friends and trying to understand, what is actually the cause of flaky tests. And hearing a lot of things, these are kind of the 4 buckets that we started to categorize them into. And we want to just give you an idea. So this presentation, we're going to go through each of these bucket areas and the problems that we see with each of these points. And then we will follow up with ways you can tackle them, or maybe kind of some mini solutions to each of these components.
Approaches, be they specific or more philosophical in nature. Yeah.
That was a good word.
That's free. You can have that. Approaches.
So flakiness, as we mentioned, can arise in these 4 common brackets per se: test design, test data, test environments, and it can arise in tech complexities. So we'll say that 4 times fast.
Yeah, curveball, right?
So let's take a look at the first part, test design. Increasingly, we're hearing that there are problems with tests that are being designed at the UI layer. So why is this a problem? Well, if tests are only driven at the UI layer, tests can be extremely brittle, and the smallest changes in the UI can cause your test to break.
Yeah.
A good example of this on a more technical level is those of you who might use HTML on your website. If you are interacting with each of those HTML elements rather than an encapsulation layer, your test will break because you're driving these tests at the HTML layer or the UI layer, making your test extra brittle.
Yeah, absolutely. That, as everyone who's been in testing for really any period of time will know, the UI layer is the single most fragile portion of your application because it's the most prone to change as things evolve and circumstances were placed in change.
Yeah. So 4 good words to keep in mind when it comes to test design are: you want your test to be stable, usable, easy, and reusable. So that's just kind of things to keep in mind as we talk about test design. Next up, a really quick tidbit on test data. In some instances, you have poorly designed test data that may not cover all the possible test scenarios. Testers often cover both the positive scenarios that come up and also the negative scenarios, but there are times when we forget these edge cases. So it's important to pay attention to these edge cases. Of course, there's also an interaction with test design and test data. These 2 things should work together. If you have a test design where your tests are working independently, then your test data should also be able to work independently. If one of your tests are leaving data for another test, or one of your tests is dependent on data from another test, the data should not be corrupted in order to ensure that the test is working properly.
Yeah. If data is the lifeblood of our tests, we need to go the extra mile to make sure that the data we are leveraging is valid at all points in the chain. You can't just assume it's good at the beginning and then assume it'll be good at the end. You need to make sure that it's maintaining its integrity throughout the run.
Yep. Next up, the test environment. Test environments commonly overlooked.
Yeah, very much so.
And I think they're also often thought about as only the computer you are running your test on, which this is not the case.
Nope.
This is part of it, but there is definitely more to it than just your computer.
Good morning, everyone.
Good morning. Including things like services, other pieces of your own application you might be interacting with, your internal environment, or it could also include things like network across the wire. So it is important to expand your scope or idea of what actually is included in your test environment.
The easiest way to consider that is just anything your application interacts with. And that could be as basic as the computer it's on to anything as, say, abstract as other calls it's making externally, or alternatively, even the network you're on. This is all parts of the test environment, and they should all be considered.
And then finally, we have tech complexities. This one was a little bit harder for me to wrap my head around, Nick, I can't lie.
No.
But
well, you can, but you shouldn't.
This does not involve, changing the way applications are working, but the tech complexities that are arising. So say you're dealing with basically an
Asynchronous, ladies and gentlemen, asynchronous.
Technologies. Testers will then sometimes have to put random timeouts in their tests. And when you do this, you can cause some problems in both directions. First off, if the timeout is not long enough, then your test might fail because you didn't wait long enough. And second off, if your timeout is too long, then you're going to waste a lot of time.
Yeah, these are all things we're going to be talking about and discussing later as well.
So we wanted to bring up all of these as just kind of some context to set the stage. And now we're going to go into some ways that you can fix a lot of these issues. First off, we're going to cover our first topic, which is test design. If I can make the slides change.
Slides are tough, ladies and gentlemen. Do not judge. Do not judge. Slide decks are hard.
So we talked about test design in the perspective of UI testing and making sure that you don't only do your test design from the UI layer. Let's take a really quick basic example. Say we have a website application and there are two fields, field A and field B. And at each of these fields, we put in a number. Say in field A, we put in 4, and in field B, we put in 5. Now say there's some type of logic that runs, maybe multiplication or addition. And depending on what logic you run, you get different results, 9 for the addition logic and 20 for the multiplication logic. The first way of driving and testing this functionality to test the actual result of 20 is by driving your test at the UI layer. You could script the test to go to the website and put in your values. We can then click multiply, then compare the expected result with the actual result. But let's switch it up. Let's say that we're changing the multiplication button or the expected value or the actual value changes. This test would then fail. This is also a bad test rate because there's a huge dependency on one part of the test on a different part of the test. For example, your input value 4 interacts with the multiplication button and the expected result.
Mm-hmm.
And this is why we actually asked the previous question of, we're sure most of you have heard of the test pyramid strategy and what you, as far as the number of tests you should be running.
Mm-hmm.
And here we've kind of flipped the pyramid a little bit sideways.
Just a little.
I was sick of seeing the basic pyramid structure.
It's boring.
So we went left to right. And in general, you can see that the largest number of tests you should have in your testing suite should be unit tests.
There we go. We got it out. Yes, unit testing is so very important because you're hitting right at the source. Your user interface is going to be calling those underlying functions and methods all day long. And if you can make sure you've got them locked down tight, if you know your addition function is always going to tell you 9 and 4 is 13, then your UI-based tests are going to be more resilient as well because you no longer need to be concerned about the underlying mechanisms.
Absolutely. So that's why we were a little bit surprised to see the current results. But it is important that, you should always have more unit tests than service tests, UI tests, exploratory tests, all of that. And so why do we want to test more units? Because units as a whole, they're stable and they're strong. So you know when something fails, what unit it ties back to directly. So you can take complex UI interactions and utilize them. And we can make these parts of the test that are smaller, take these smaller parts and put them together to actually make them larger tests in general.
Exactly. You can be modular with it, as it were, and expand out and take different pieces and make them work in concert to form an overall greater whole.
Anything else you want to add for this slide?
No, I think we're good.
I think so too. And so a way to think about this is implementing page objects in the real world. And we're going to take the common example, the e-commerce site. So you can split this up into two kind of categories, the what and the how. I'm sure everyone here has at some point gone online and ordered something. I know I way too frequently use Amazon. So that's what I was thinking of for this example.
If you've never ordered anything online, please answer in the chat.
We can talk.
Yeah, let's chat.
So on the left side, we have the what. And in general, we want to add an item to our cart to order.
Seems basic enough, right?
And then on the right side, we want to talk about the how do we actually do this. The first step is you want to click on an item with whatever name that we're interested in. So you're going to click item. Then we want to set that element with the name to equal a quantity. So say we are buying our favorite book and we are buying 5 of them. We're going to use set element. And then we are going to click on the button labeled place in cart. So we're going to have to first find that button, and then we are going to click it where it says add to cart, place in cart, etc. So this is one example, and it shows that you can how it can be summed up, the 3 components of the how into the 1 component of the what as add item. So this is defined piece with an input and an output. So now if this breaks, you will be able to find these breakage points much more quickly as we defined it as add item, and you can fix it later. So a few key takeaways from this slide is separating the what from the how. The how you do things will change often, and when they do change, you can pinpoint these elements much more easily and much more quickly. For example, say you're only changing things for the set element, then you only have to identify that second band there, rather than the first band, the second, and the third band. And it's just way easier to create changes to the that one band than it is to the entire UI test.
Yeah, absolutely. What we've done here is we've essentially unpacked the simple concept of add item into its component parts, and we broke it down into, as you can see on the right, their objects and some associated methods. This kind of, I don't think the right word is abstraction, but it's the word I'm going to use. This kind of decomposing into individual components is going to help you pin down exactly what you're doing to make the UI go, so to speak. And having a good understanding of this is going to be one of the most important pieces of foundation that you will build upon as you create more thorough UI-based test suites.
All right, time to move on to the second part.
Here we go.
I think we covered test design pretty well. Now we got to go into test data. So here we are going to talk all about separating the test data from your test design. As we touched on it in the first part, but here we want to go a little bit deeper into it. So if we start by looking at the right side of the chart, your test should run independently of your test data. We do this because we want to make sure your tests get done on time and you're not like waiting on anything or relying on your test data.
Hate it.
That's pretty funny because we're gonna have to talk a lot about waiting.
We're gonna talk about waiting. So remember that I said I hate waiting, so you can use it against me later.
But in order to do this successfully, you need to limit the data dependency between different tests. Let's take 3 test cases as an example: test A, test B, and test C. So let's say test B relies on the test data from test A, and test C relies on the test data from test B. And unfortunately, test B was a little flaky. We didn't.
It blew up on us.
It wasn't great.
No, it was bad.
And it didn't end up creating the correct data that we needed for test C. Unfortunately, because test B failed and created data that wasn't great, test C will also fail. Now, if we had independent data sets for test A, test B, and test C, then you could run these tests independently and figure out whether or not the problems were from a test design issue or a test data issue.
Yeah.
So there are 2 types of data you will interact with on a daily basis. The first is test-specific data, and the second is reference data. Test-specific data is something you will be validating at the end of a test. For example, let's talk once again about Amazon.com.
Yes.
Your test-specific data would be ensuring that the money from your debit account has been debited. You're validating this is occurring at the end of your transaction. Then there's reference data, which in this example could be your name or your address, things you're not necessarily validating while the test is actively going on.
Mm-hmm.
But as you can see, having the right test-specific data is important where you can get around not having necessarily the right test reference data.
Yeah, to break that down for you a little bit, if you're using Amazon to validate that your debit account is being let's say, taken from successfully, you don't much care who's actually logged in, but you absolutely do care how much money is in your bank account. So in that example, the reference data is going to be all the stuff that doesn't matter, our name, address, while the test-specific data is going to be that bank account.
Yeah, and you just highlighted it. These data types will be used differently. So in the same way you separate the test design, you should also separate the test data. This lets you roll things back and also reset to kind of like a known state. There's data you use and data you check. Data you check is the part you have to roll back. So when you're using databases, you can conduct these tests at a transaction layer and roll back the transaction to check if everything is A-okay and you can continue on.
Yeah.
So data and databases are an external system to your application. but there are also definitely additional external systems we have to talk about.
Many, but I'm not going to let us transition slides just yet.
Sounds good.
The word of the day for this slide, it's not completer anymore. The word of the day for this slide is isolation. Our tests need to be run in isolation, and our different types of data, reference and test specific, should be isolated as well so that you can transform the information, modify it without ruining everything else.
Nice. That was good. That was a good
You like
wrap
that?
up.
I like that. I think it was good. I think it was really good. Cut.
So, as we talked about, we're going to now talk about test environments. So we did talk about test data that you'll be interacting with, but we also mentioned there is a lot more than just test data.
A lot more.
Boom, boom, boom.
Bum, bum, bum.
And so with that, not every single test should be talking to other systems. You actually want to limit those interactions in general. It's important to limit the number of tests that interact, because the more tests you can write that don't interact, the better you are at the end of the day. And it's also good for practice to separate tests into the internal part and the external part, and then parameterize those connections. It's basically meaning, break those connections down into two. Here's what I'm saying, and here's what I'm trying to get at. This builds an abstraction layer, which lets you do really cool things like limiting the calls to the external systems, parameterizing connections, as well as using mocking or virtualization.
Yeah. Not the kind of mocking where I make fun of Bria for not being able to pronounce words, a different kind of mocking.
Yes.
A worse kind, but a more important kind.
So one of the ways where dependency on an environment can create problems is a slow network access, or maybe unavailable servers. There's so many ways we could honestly think of and talk about. So one of the ways Google overcomes this is actually using hermetic servers. To sum this up, it's basically a server in the box. And rather than using an external system, you are using everything on your local machine. So you can load your entire server on your machine, and you don't have to worry about sending a front-end request and getting a back-end request. This is basically a mock server, which is on your machine. So once again, you don't have to rely on a network connection, and the server works as expected when it hosted locally.
Yeah.
So through all these three solutions that are outlined on the slide, limiting the calls to external system, parameterizing connections, and mocking servers, there is one downfall. And we recognize this. This isn't the real world. And so what we're talking about on this slide is faking external dependencies through mocking, virtualization, etc. But it is important, and these are helpful tactics to use when you're trying to limit your dependency on environments. But at the end of the day, you always care about your end user experience. And it is very important to actually take all of the tests once you feel like you have reached a certain point and actually test them in the real world, just to do like your own sanity check of, hey,
absolutely,
this works. My end user is going to have a great user experience.
Yeah. And this, again, you can call this reducing dependencies, but one of the major benefits here, and this is a classic troubleshooting move, is that you're reducing the number of moving parts. If our test is breaking and we don't know why, the more things that we can guarantee are working okay, such as outside dependencies through mocking them, the better a time you'll have trying to narrow down exactly what is going wrong.
And then let's just read out, I know we are getting some questions. Let's read out one here, Nick. I think you already answered. But what if we have a test case such that it is compulsory to pass test data from one test to another?
Yeah, and this question was asked by our good friend Nitesh, and my answer to that is that's super valid. There's absolutely going to be circumstances where you must pass data from one place to another. That's inevitable. It's completely unavoidable in some workflows. Here's what you're going to have to do with that in mind. So the first thing you should do is you should reduce the number of those tests as much as possible. Figure out exactly what it is you're trying to test in that moment and make sure you're testing only that, and that the test that requires that external data isn't doing double duty in any way. Then you're also going to have to be aware somewhere in the back of your mind that that test is always going to be a little bit flaky. It's inherent in its structure, and it's nothing you can do about. At that point, it's going to be on you to go the extra mile and make sure all the other tests in your suite are working as well as possible. This means that you're still going to get those passing rates up higher while still acknowledging that there is the possibility for things to go wrong.
Nice. So that was just also a reminder that we are monitoring questions. And so we have gotten a few. Please continue to keep asking them in there. I'm trying to keep Nick busy over here with
Yeah, of
answering
course.
questions.
I've been on my phone this whole time. It's been a disaster. Keep those questions coming.
So the final component we did want to talk about is for understanding flaky test is tech complexities. And
Good job.
I do know here that the words are about to be really hard because I have to say that one word over.
Tech complexities.
Asynchronous.
Tech complexities.
Tech complexities. So this is oftentimes dependent on the way applications are being built. And the way applications are being built today is way different from the past. I mean, even if you look back a year, 2 years, things have drastically changed. For example, Angular
Going
JS
well
as
so far.
one example.
Going really well.
We're going to switch slides. So say you're using Ajax calls or Angular JS, you're getting a response. But also some technologies, we know you just don't get a response. And let's talk about technologies where you're not necessarily going to get a response. Some teams might put in random wait times to see if the response ever occurs. So say a tester puts up a 5 or 6 second wait time, expecting feedback from a website that they're testing. This may cause 2 challenges that we mentioned before. The 5 seconds may not be long enough to get an accurate test on whether or not it passed or failed, or the 5 seconds may be too long. If it's not long enough, you won't get a response. Your test case will fail. If it's too long, you will get a response, but this really isn't scalable time-wise.
No, not at all.
Imagine wasting 5 seconds every test you ran.
This runs right back around to what we were talking about earlier. 99.5% pass seems good, and it's only 5 seconds. But if you're running those tests with the frequency you should be running them at, that 5 seconds is going to absolutely dominate.
Yeah, and it also it slows things down. It makes everything, the word you always try to avoid, brittle, and you don't want to do that. So you're not really solving a problem. You're just creating a different one.
Yeah, you don't want to replace problems with problems, kids. It never goes well.
Never goes well.
It's just like lying to get out of a lie. It'll always catch up to you.
So there's ways to help Ajax calls. The first is a callback method. A callback method tells you when the service gives you a response. Next up is a polling interval. It could also be useful where when you're writing test codes, you could set up the responses in small intervals. Say you could set up a test for every 0.5 milliseconds. Did you get a response? The key here is to keep your polling intervals very, very small. The third fix, and one that we'll be talking about in a bit of detail that can be used in TestComplete, is the wait until. So an example for the wait until is we were talking with someone and they were having problems with their application because at one point of their workflow, you upload a file. And this test took a different amount of time based off of the different size of the file that they wanted to upload. And the testers were facing a roadblock of how do you test this? Because all file sizes are different.
They're all going to be different. How the heck am I going to construct a wait time that is narrow enough or small enough to be, well, not onerously long, or still long enough to accept the fact that I could upload a text file today and a movie tomorrow?
Exactly. So instead, you have to think about what other ways can you successfully test this. And in this case, there was a page that would pop up after the upload happened.
Yeah, it was a page or some element on screen changed to signify that the file had been received.
Exactly. So if you set a wait until the thank you for uploading showed up or some element changed,
something like that,
then that is a way you could confirm that the file was uploaded successfully. Yeah. And it's really that type of thinking, like kind of outside the box, to be quite honest, that can be really helpful and important when you're trying to look at your test from a different angle, or you're having different things that are being uploaded with different wait times, and your wait times are definitely varying on when you're going to get a response.
Yeah. And this is a adjectives fail me, but one of the ways I think of this is that your application is talking to you in a number of different ways. It's telling you what it's doing. It's telling you what's going on. Sometimes this is super obvious. For instance, I work on an application where every time you submit something, a brand new pop-up shows up saying, hey, you submitted it. That's very clear communication and makes it easy for me to validate that I did indeed submit something successfully. In other cases, like with our friend who needed to upload files, it's not as apparent, and we needed to think outside of the box and figure out some other way to determine, just using the user interface, that that file had been uploaded. That's what we mean when we say out of the box thinking. You need to be lateral with how you interact with the application, because it's going to talk back to you and tell you what's going on in a number of different ways, some of them less obvious than others.
And, there are still people we talk to that say, well, we really don't have a response. And if there's no response, then how am I going to test whether or not my test was successful and whether it passes or it fails? Well, I challenge you to think about this in a few ways. If there isn't an immediate response, there might be one further down the line that you should really think about. And this is kind of getting back to what we thought about thinking outside the box and what we just discussed on thinking about a thank you page that might appear or a different element. So, and then I challenge the other people to say, well, there still really is no later result. Then why are you testing it?
Yeah.
There might be a reason. And we do talk to people that have a reason for testing it, but if there's no expected result to check, then what exactly is your test running and why is it running?
Yeah.
I think there was a question you wanted to answer.
Yeah, there was a quick question. So we're seeing a lot of terminology on this slide. And on the left column, we've got AJAX calls, callback, polling interval, wait until, what is going on? So a callback is when the application itself talks back to you. And callback is a defined term, but I use it to mean anytime the application very clearly communicates, you performed action A, I received it, processed it, and I'm done. That's a callback. That's the easiest way to make sure that something has happened because the application's talking to you. A polling interval is slightly different. A polling interval is you constantly checking the application to see, are you ready? Are you ready? Did you do it? It's like being on a road trip with your old man and you keep bugging him if you're there yet. And that's what a polling interval is. It's consistently checking to see, is it there? Are we good to go? And then a wait until is, well, a special method available in some testing frameworks. We're going to see an example of it that is consistently checking and waiting, somewhat like a polling interval for an object to appear or some other action to be triggered before we proceed.
And on the right side, this is when you're telling me there's still no response, but we need to do some type of testing. And there are a few different ways you can handle this, things we've actually touched on previously in this presentation around virtualization or mocking. Mocks are great for testing actions. Virtualization is really good for making sure your logic makes sense. And if you want to see what happens if you enter in the wrong numbers to a common function, for example. And these are really good methods that you can use to get fast feedback or to see how a system might run if there's if there is not necessarily some type of output that's just this plus this equals 10. So these are all different levers you can pull on and things you can rely on to successfully start to implement a more successful testing strategy. And given we are, wow, it's already 9:40.
It's crazy. Time flies when you're having fun.
Still a lot to cover. Real quickly, we'll fly through this slide. And at the end of the day, when you take all things into consideration, you've already taken care of the test design, test data, test environment, and tech complexities, and they're not resulting in flaky tests. You will have some tests that are flaky and some tests that are breaking.
Yeah.
So first and foremost, if you have UI tests that are part of your acceptance build, these tests should absolutely never be flaky.
Never, never, never.
If these tests are failing frequently, then they should not be a part of your acceptance build criteria. If you take your flaky tests and put them with your healthy tests, you can get wrong feedback. You'll get incorrect feedback from the suite, which can limit how developers respond to the test suite and really just be quite frustrating, quite honestly.
Yeah, it's enormously frustrating. Another benefit to this is that if you are used to having acceptance tests where, one or two tests fail, then eventually you'll hit a point where you stop investigating which two tests those are. You're going to have the usual suspects in the back of your mind, and you're not going to go the extra mile to figure out, well, wait a minute, which test is actually being flaky here? I have a good friend who got in some hot water about that. Some bugs got out the door because the test we thought was failing was not the failing test at all. And we had just become accustomed to not passing all our acceptance tests. Do not do what he did. Do not fall down that rat hole. Keep them separate and make sure your acceptance tests are healthy and in the green.
Yeah, and some quick best practices. If you set up a practice of segregating your flaky tests from your healthy tests, that doesn't mean necessarily we will continue to increase the number of flaky tests on a daily basis. Actually, you should set a hard limit on the number of flaky tests you're willing to have. So you should set a limit on the amount of time that test can be kept in, let's say, the flaky test bucket. So say you do 3 days is the limit. You need to make sure that those tests, the flaky tests, are out of there by 3 days. Set a hard limit and hold yourself and your team accountable to this limit, so you don't just keep adding to your flaky test bucket.
We do not want to increase our technical debt. The flaky test bucket should not be a final destination. It should be a transitionary point as you rework your tests to be even better in the event that you can.
And, the number one problem with dealing with flaky tests is it's impossible to be rid of all of them.
No,
we recognize that. We're trying to give you some different methodologies or practices that you can use to help reduce the overall number of flaky tests. But it is important to still recognize there will be some flaky tests. And you have to set aside the time to actually analyze your flaky tests. And it's important to make that a part of your regimented process for dealing with your tests.
Yeah. Just like everything else, no testing process is perfect, and we need to account for the fact that imperfections will arise. We can be in a great position to handle them, but we need to put ourselves in that position by understanding which tests are prone to error, which aren't, and having recovery strategies in place.
So we've talked about the things you can do to reduce the number of flaky tests. And let's say from our original example, we knocked it down from 0.5% to 0.2%. That's really great.
Yeah.
But there still are some flaky tests. So what do you do?
I don't know. What do you do?
Well, one thing you can do is use math.
Oh boy, I love math.
Here's where I get excited, and Nick just looks at me.
Hey, stop.
So we're going to fly through this slide. If you have more questions, we just want to make sure we get to the demo and the Q&A. But really, this is honestly just like bringing you back to your calculus days of using confidence intervals with a sample size, a desired confidence interval, the probability, and the 1 minus the probability. So in this example, we have 50 as our sample size with a 95% confidence interval. Our probability is 29/50 for a pass rate. And then we have 1 minus the p-value.
Of course.
So with that,
1 minus the p-value, ladies and gentlemen. It's just that easy. I think there's blood coming out of my ear.
So we have a binomial confidence interval. You all remember this formula.
Of course.
You remember it?
P plus or minus Z.
1 minus alpha over 2. Nice. And so we also remember when you're looking for the Z value of a 95% confidence interval, remember searching through all of those tables?
The tables, baby.
Those tables.
Wolfram Alpha, save me.
It definitely saved me too. On the Z values, the common one for 95% is 1.96.
Of course.
So we have all our variables. At this point, it's plug and chug and see what we get.
Mm-hmm.
And when we do this, we can see that our confidence interval basically says that we are 95% confident that the proportion of tests in the target population would pass between 44 to 72% of the time. So rather than us just saying a number of 58%, we can get an idea of the population as a whole based on the information from this simple math equation.
Yeah.
So
boiling this down once again for the slow kids like me, what this is telling us is that after performing this calculation on our test set, we now know that the vast majority of the time, 99% of the time, our entire suite is going to succeed between 44 and 72% of the time.
95%.
I don't know if that made it anymore. 95% confidence interval. I knew that. 95%.
All right. So now it is time to switch, and we are going to switch over to your computer.
Okay.
And
let me go ahead and turn that on.
Demo.
Okay. So they've passed me the reins. Huge mistake, but we're going to work with it anyhow. And I'm just going to begin sharing my screen. So bringing this up, share screen to desktop. It's the lovely question box. Thank you for all those questions as well. Keep them coming. So quick tech check, everybody. Whoop. Can everyone see the nice smiley face I've drawn on my monitor and my mouse moving around?
I don't know if I'd call it nice, but yes, we can.
Okay. Personal attacks will not be tolerated. All right. So I'm just going to guess that we can all see it. Bria, yes?
We got feedback that we're good.
Okay. That's scary. So what we're looking at right now is TestComplete. And TestComplete's an enormously powerful tool because it's going to help us accomplish a lot of the things we discussed today. Let's start with the very first thing we talked about, the breaking down of simple actions into their more detailed, so to speak, component parts. Well, let me give you an example of that right now. I'm actually going to go in and I'm going to build out a very basic e-commerce based test here. And we're going to see how TestComplete can take the actions I performed and break them down into the individual operations, actions, and methods we're leveraging. So at this point, we're just building a brand new keyword test here. Stick with me, folks. I hope I can type. That's how you spell commerce. Brilliant. All right. So we begin recording this test. And for those of you who are unfamiliar with TestComplete's way of handling things, a lot of its functionality, in fact, the vast majority of its functionality, can be accessed without any scripting at all. All you need to do is hop in and interact with your user interface like an end user would, or potentially like our manual testers already are, and we'll build out a test based on that. So today, that means we're going to do a little bit of e-commercing, and I had a special request for this one earlier on, so we're going to go ahead and visit my very favorite website, the Hot Sauce website. Now, the Hot Sauce website is indeed an e-commerce site that sells, well, it's right in the name, hot sauce. So we're going to navigate over to that, acknowledging the fact that nothing works perfectly and Firefox seems to be uncooperative. We're going to navigate over there and we're going to build out a sample test. There we go. Hey, beautiful, I missed you. So we're back in the hot sauce site, and now I can just interact with this like an end user would. That means I'm going to go ahead and I'm going to search for a specific product, in this case, Green Ghost. I'm going to go ahead and add it into my cart, and then I'm going to close the cart down. There's nothing really advanced going on here, and TestComplete's tracking everything I do. Now, at this point, I could insert a validation here, but I'm not going to do so. I want to make sure we leave time at the end for questions. So I'm just going to go ahead and remove this from my cart, close the cart down, close the browser down, and then stop that recording. Now that I've told TestComplete I'm done recording, you can see it popped itself right back up. It took all the actions I performed, and it used them to generate this list of commands right here. These are the step-by-step instructions, and we'll note that they're broken down for us. It doesn't just say, hey, you added Green Ghost to the cart. It's saying, hey, you went in, you searched in that search box, which we can see in that first line. You set the text and you pressed enter. It's dissected this down for us. We've taken the generic web page with its HTML, JavaScript, and CSS styling and decomposed it to individual objects present within the page. Now, I could talk for 40 to 45 minutes about how TestComplete's beneficial.
But I'm not going to let you do that. I'm sorry.
She's stopping me. I'm getting there. You know the old stage shows where they come out with the cane and they pull you off? They're creeping in from the side here.
That's what's happening.
It's what's going on. So we can see here it's taken those actions and it's broken it down. It knows that we clicked into the search bar, it set our text, and we used keys to submit it. This is a basic example of how your testing tools might leverage objects within your page and that page object model, and that's what we see here. Okay, so that's a basic example of the page object model. If you've used TestComplete, you're likely familiar with this in one form or another. Well, what else can we do? Well, one of the other neat things you can do with TestComplete has to do with the waiting for different objects, trying to make sure something's appeared. For instance, if you have, what is it, Priya? Asynchronous JavaScript?
There you go. That was much better than I did.
I was clever line inserted here. Make your own joke. Yes. So we have a number of different wait methods available to us. Here's something that's useful for desktop-based testing. So I have an application on my machine, and it can sometimes take a while to load. And I know that I want to act as soon as it's up and ready to go. Now, as we mentioned before, I do not want to set generic 10-second wait times, and I do not want to undercut this and try to go too soon and fail my test that way. Well, TestComplete has a number of different options when it comes to waiting. This is a very basic one we see here. It's this line, and I'm going to zoom in on it. But what it's essentially saying is that we are waiting for our orders process to exist within memory. And if it does exist within 2 seconds, that's that 2000 value we see there, we're going to log a message saying, hey, it started successfully. And if we were building out a more comprehensive framework, we would then nest additional test actions within that if statement. Then I have an else statement just letting me know, hey, if more than 2 seconds have passed since we invoked the application, we need to put a pin in it and move on. Now, there are so many other things I can show you within TestComplete, but I'm just going to give you a high-level overview because we are a little time pressed. So just like we see a wait process in here, we can also wait for objects within our web page. So if you have, what kind of JavaScript, Priya?
I'm not doing it.
Okay, I'll do it. If we have asynchronous JavaScript on our page, we can use wait object methods to wait for that asynchronous JavaScript to load before we drive actions. This approach is equally valid whenever there's a long wait time present. Maybe you're making a database check. Maybe you've got an iframe. Either way, these wait methods are going to make it so that you act as soon as possible and not a second later and not a second too soon. I'm going to go ahead and put a pin in this for now so that we can turn it over to questions. I want to make sure we have that amount of time to discuss these things.
Perfect. So we got a question specifically in relation to TestComplete, keyword test, and project items. Is there a project structure you would recommend to help your tests run more reliably? I have many reusable tests to help tear up and tear down each test, but I would like to look at isolating each keyword test to ensure I can run any keyword test in between the tear up and tear down test. I want to make sure I don't cause any more issues.
That is a very valid concern. We definitely don't want to cause problems by solving problems. That's always a losing gambit. So scrolling back up to that question, which I think Bria Mark answered for us. There we go. So
Sorry.
Scrolling back to, no, that's fine. No, please keep it up. Anyhow, so how do we make our tests run more reliably? Well, it all feeds back to what we were discussing earlier. If your tests are dependent upon external resources, if they're making calls outside, if they are heavily environment dependent, we want to isolate those out. Now, at a high level, you're doing the right thing. And I want to emphasize this for the assembled audience. What our friend Jenny is saying is, hey, I already have reusable tests that set up and tear down when we're done, making sure maybe the data we're using is valid, that the environment we are within is ready and good to go. You should absolutely pursue that approach. And one of the things I'd recommend to Jenny is to extend that modularity concept. One of the things I have going on within my TestComplete project is this modest test library on the side there that's built out of reusable components that I can use over and over again. So by using that process, by structuring it like that, you can have a better understanding of how your tests are divided, what they're specifically accomplishing, and how they fit within the greater whole.
Great. And so we do have another question, and I think you actually touched on it earlier. Can you define your meaning of flaky test? I'm familiar with the term, but I've also seen it used for different scenarios of broken tests or just in general tests that don't work.
Yeah, so my personal definition of a flaky test is very basic. If you can run a test one day and with no other major changes have that test fail the next, that is a flaky test. Reliable tests should run green, whether you run it at 2 a.m, whether you run it in the middle of your testing process or not. They should be able to stand on their own. A flaky test is any test that's prone to these problems, tests that will fail because of, rearrangements of your environment, other experiences within your user interface. That's what flaky means to me. I don't know, Bria, do you have your own personal definition?
No, I think that was pretty good summary in general. There are a lot of different definitions that you'll see out there. And I think it is exactly what Nick said of it's not really a reliable test that will pass every single time. And sometimes you cross your fingers and hope to goodness like that it will test. And sometimes, unfortunately, it just doesn't.
It just doesn't.
And that to me is kind of a flaky test, is like it's kind of a hit or miss and you just never know. And that's a little stressful.
Yeah, when I'm working with clients, I divide tests into 3 categories. We have our green tests, our strong tests, the ones that we know are going to do that work for us. We've got our tests that are broken. They don't function right now for whatever reason or the other. And if your test lies somewhere in between, well, sir, that test is flaky.
Well, we're really excited to get a lot of questions. Please keep them coming in the question and answer box. And we do want to say, yes, this session is being recorded and this will be sent out in a follow-up email that you're more than welcome to share with people. We've gotten that a few times. Additionally, if you have a very specific question to maybe your type of application or what you're running, then we will try to answer that definitely just offline, just to try to make use of everyone's time online. But I think oh wow, we're getting a few more here pop up.
Here we go. Keep it coming.
Have you looked at another good one to
Let me see if I can find something nice. I want to give something that's useful to a wide variety of people. Bria, do you see one that looks good for us?
I think so. Well, we have a question on wait until again.
Yes. So wait until is also an option available to you. So for those out there, so wait until is essentially saying we want to continue in a paused state until a certain condition occurs. Now, within TestComplete, you can do the exact same thing, but the specific method isn't called wait until. What you'll actually end up doing is wrapping your wait within an if statement or a while statement. Same basic concept, same end result of we paused execution until something happens, but we're just packaging a little bit differently.
And then we have some questions here on, getting started with TestComplete. How do you organize a framework, best practices with TestComplete? And we'll be sure to send you all that documentation right after we get off this webinar. So you will have that made available to you in general for sure.
Yeah, so here's one question I want to answer. I don't know how much time we do have left, but Rama wants to know how using the page object model can help overcome the flakiness of our tests as they relate to UI changes. Well, I can give you a classic example in the TestComplete world. So TestComplete's tests are object-based. We identify them based on core properties, things that aren't subject to change. This means that if your login process is modified and maybe the buttons are rearranged or maybe it's evolved, well, TestComplete's still going to be able to find those objects, even if they've moved. If your UI tests are driven by image-based or, God forbid, coordinate-based actions, that test will fail with even the slightest bit of rearrangement, and that could be within the user interface or in the environment.
Goodness gracious, coordinate.
Yeah, coordinate points.
You were not having that.
Don't do it, ladies and gentlemen. Just say no.
So with that, we have about 2 minutes left. So if you see one more question, Nick, that you want to answer on here, we're trying to sort through them all.
Yeah.
There's like a big wave. And so there's just like 12 in our box. We're trying to find the most applicable ones to everyone.
Okay, let's see. Okay, so is TestComplete, here's a question looking towards the future. So is TestComplete going to release or deliver any features based on artificial intelligence for IoT automation, potentially some self-healing mechanisms? So I can't give too much away now because it's all still in development, but we're very much aware of that shift in the industry. And just as always, we're going to make motions to keep ourselves at the forefront of what's happening in the testing space.
Wow, that was a good answer.
You like that? You like that? Maybe I could do marketing.
Detour. We definitely have a great pulse on what's going on in the industry. We know where TestComplete can continue to be an even better product for our customers, and we continue to ask for feedback. So those are things we are going to continue to do. And I think the best thing I could say is just stay tuned.
Yeah, stay tuned. Keep your ear to the ground.
And then we are getting requests for future webinars. Always feel free to shoot us an email with what you would like to see in the future. With that, we want to thank you all for joining us for over almost a full hour.
Yeah,
we really
crazy.
appreciate your time.
Good work, everyone.
Hopefully you got some valuable information out of this. And I know, Nick, I had a great time. Thanks for hosting with me. And we appreciate all of your interactions. This was a wonderful webinar.
Yeah, thank you all. I hope you learned something new. I hope you had a good time. And hey, we host these all the time. So I hope to see you in the next one.
If you have specific questions, we will get in touch with you. We're getting a couple questions on that. And also to the people promising us to do more unit testing, that makes our hearts happy.
Yeah,
I feel
this
relieved.
is great. I feel a great weight has lifted, really.
That's the best thing that could have come out of this.
Some say his heart grew 3 sizes that day.
Thank you all so much and have a wonderful day. Bye, everyone.
Later.